So it is a branch of chemistry that deals with study of chemical changes that occur by passing electric current through a chemical system. That's what we call electrochemistry. So electricity is usually generated by the spontaneous occurrence of many chemical reactions. Somebody may define it as generation of electricity, by spontaneous chemical reactions. What do we mean by this term spontaneous? Spontaneous chemical reactions. When somebody talks about something spontaneous, or spontaneity, you should know that this is something that happens or arises without apparent external cause. It happens due to an internal cause. It's a self-generated. Okay? Something that happens without an external cause, we can call it something self-generated. Okay, something impulsive. So, generation of electricity by self-generated chemical reactions. Reactions that have no external forces that are aiding them to occur. So electricity gets generated in that way, and the whole process, or the whole branch of chemistry that deals with that, is what we are calling electrochemistry. Now, if that is what we call electrochemistry, and we are dealing with electricity or electric current, remember with electrochemistry, we shall basically see what we call electrolytes, and electricity is being conducted. So anything that involves electricity, then there should be conduction of that electricity. And that brings me to something I'm calling modes of conduction. How is electricity conducted? By various substances. So if any substance allows electricity to pass through it, that substance is called a conductor. Any substance that allows electricity to pass through it is called a conductor. Iron nails, copper wires, aluminium foils, all do allow electricity to pass through it. And all of them are solid substances. So such substances are called conductors. Then those ones opposite to conductors, so any substance that doesn't allow electricity to pass through it is obviously called a non-conductor. So if I talk about non-conductors, you can think of things like wood, those solid substances that don't conduct electricity, paper. You can think of soil, dry soil, and you can think of plastic. All those substances that do not allow electricity to pass through it are called non-conductors. Hello? Nzirabye naye ndi mu kazuumu lesson wano. Sawa 5 gye tugenda okukolako. So such substances that do not allow electricity to pass through them are what we call non-conductors. All right. Now, these conductors here, we have already seen that they are substances we call, we have divided our substances into two. We have divided them into conductors, and we have also divided them into what we call non-conductors. Now, these conductors here can also be divided into two types. They are what we call metallic conductors and non-metallic conductors. Does any of you know any non-metallic conductor? Any substance that's not metallic but does conduct electricity? I've already given you examples of the metallic conductors. I've given you an example of copper, iron, aluminium, and many others. All those are metallic conductors, but they are substances that do conduct electricity even in the non-metallic state. So those non-metallic conductors, we can have an example of graphite. It's a non-metallic conductor, but still most of them, apart from graphite, have another name we generally give them. That name is what we call electrolytic conductors. Let's keep electrolytic conductors for a later case. For now, let me go ahead to elaborate about the metallic conductors. So what do we know about metallic conductors? So metallic conductors do allow electricity to flow them without undergoing any chemical change. That's why, as I was beginning the topic, I said this branch of chemistry deals with the start of chemical changes that occur by passing electric current through a chemical system. So these are chemical changes that do generate the electricity in these systems. However, we are seeing that the metallic conductors, for them, allow electric current. So we are saying metals or even alloys. Most alloys have metals within them, apart from one which has a non-metal. That is a steel. Steel has some carbon in it. It consists of carbon and iron. But metals or even alloys do allow electric current to flow through them. Allow current, which is electric current, to flow through them without undergoing any chemical change. Can you imagine? You have a copper wire, electricity goes through it from one point to another point. You touch it, it even shocks you, but the copper wire remains the way it is. It has no change chemically. So that mode of conduction is a mode of conduction that involves use of free mobile electrons. Free mobile electrons. you may call them delocalized electrons. You may call them delocalized electrons or free mobile electrons. And we have already seen examples of such metals. They include copper, they include iron, silver, aluminium, and so many others. Now that mode of conduction, whereby metals or alloys allow electric current to flow them without undergoing any chemical change, and by use of free mobile electrons, is wholly called, the whole of that process is called electronic conduction. The whole of it is called electronic conduction. That's what we call the whole process by which metallic conductors or alloys conduct electricity by flow, by the electric current flowing through it and being transferred by the use of what we are calling free mobile electrons. Are we together?
Yes, teacher.
Okay, if we are together, then allow me proceed with that entire process. By the way, I think it could be very important if I detail the process by which these metals conduct electricity. Let me, for example, look at copper. I think this would be very important. Let me specifically look at how copper could conduct electricity as a case, and how do the delocalized electrons come about. Now, usually a metallic solid consists of lots of ions. It consists of a lots of ions. For example, for copper, you may have ions. What you see as a metal has this kind of structure. That is the copper metal. For example, just a piece of copper metal that you may break from those wires. It has this kind of structure. Copper is dipositively charged. So you may expect it to have a positive charge of 2 for each ion. Each of these is a copper ion, right? Yes. Each of these is a copper ion. Copper 2 ion. With a positive charge of 2. Then the outermost electrons form what we call a sea. A sea of delocalized electrons. I think the word sea is used to show you how many they are around. So the delocalized electrons form a sea within the lattice. We call it a lattice. Yeah, the lattice of copper 2 ions. They are within there, moving throughout the whole lattice. Now, these are what I'm calling the metal cations, or the copper 2 ions. And these are the delocalized electrons. That's how any metal structure is. If it is sodium metal, then you shall have a positive charge of 1, and then the electrons all within there. Now, these delocalized electrons are free to move throughout the structure. They are not static. They are free to move without this whole structure. For example, this one, these two here are free to move anywhere throughout the structure because they are delocalized. So they have that liberty to move anywhere they want. And that's the way they conduct electricity. Now, they are electrostatic attractions. They are what we call electrostatic attractions that exist between the delocalized electrons and the metal ions. There is some force of attraction between the electrons and these ions. So during conduction, those forces are broken and make the electrons free to move. Now, further on addition of how they do conduct electricity, they always transfer from one place. They move from one position to another as they move with the electric current. Details of that will be seen if you further. I think those of you who do physics, you will see further about the electronic conduction. Now let me proceed and see what we call the electrolytic conductors. Electrolytic conductors. The word electrolytic comes from the word electrolyte. And all electrolytic conductors include, these ones we can classify them into two. We can classify them into aqueous solutions of electrolytes, or we can consider them molten electrolytes. For example, an aqueous solution of sodium chloride is an electrolytic conductor. Then molten sodium chloride. Sodium chloride can be heated to high temperatures until it melts. When it is molten to form a liquid, it's still an electrolytic conductor. Why? In both cases, they are free mobile sodium ions and chloride ions that will do conduct electricity. In the case of aqueous sodium chloride, those ions are hydrated. In the case of molten sodium chloride, those ions are in liquid form. So they will still do conduct electricity so long as there is a force that makes them free to move within the solution or in the liquid phase. So most of the molten electrolytes are compounds, and they conduct electricity using free mobile ions. Their mode of conduction is what we call electrolytic conduction. Their mode of conduction is what we call electrolytic conduction. The mode of conduction of metallic conductors, we called it electronic conduction, if you haven't forgotten. Are we together?
Yes, teacher.